Good morning, students. It's Mr. Potensky, and we are working through problems in 7.2 on page 212 of your Big Ideas Math Student Journal. Remember, we are multiplying polynomials. Let's work through these. We're doing the evens. So 2 through 24 even, 2 through 24 evens. So here at number 2, we have the quantity b minus 3 times the quantity b plus 2. So I'm going to be doing some things here in color just so that we have that visual of what is going on when we're multiplying these. So I just went ahead and rewrote that there. So we have in these problems 2, 4, and 6, they ask us to use the distributive property. So in that distributive property, the big thing to remember is each term in one polynomial is multiplied by each term in the other. So I'm going to go ahead and each term in one polynomial is multiplied by each term in the other polynomial. Okay, gotta zoom out just a little bit so you can see that whole thing. So again, in the distributive property, and actually when we're multiplying two polynomials, the whole thing is each term in the first polynomial is multiplied by each term in the second polynomial, and we see that. So when we're talking about that rainbow method, we talked about that where we took the b times the b and the b times the 2, and then the -3 times the b and the -3 times the 2. Okay, we're doing those operations. So we take this b times b, okay, and then we take the b times that 2, and then we took the -3 times the b, and the -3 times the 2. So when we get that, I'm going to go ahead and just use one color here and on the last line, or the second to last line actually, because we'll have to combine like terms. But we have b times b is b squared, and b times +2 is 2b. And then we have -3 times b is -3b. And -3 times 2 is -6. We notice that those terms right there, they are like terms because they have the same variable to the same power. So we need to combine those. So a +2 minus 3, that's going to make us end up over on the -1. So we can go ahead, and I'm just going to go ahead and go over here since I know I have that space. And this one, we get b squared minus like I said, -1. So that will just be a -b minus 6. And then box our answer. And that is the answer there to number 2. So as you go through this, it starts to get a little bit quicker. So we're going to go ahead and get started with number 4. And the other thing is we also sometimes decide, oh, we want to uh, do our rainbow method there, like so we do those up above, and we want to visualize this a little better. So we'll do those rainbows or show that we're distributing that -1, multiply it by each term in that second term just below it. And here we go. So we have a times 2a. So it's nice to just go ahead and rewrite what we plan on doing. A times 5, so that's going to be plus a times 5. And then we have -1 times 2a and a -1 times 5. And we just a times 2a. We're going to have 2. A times a is a squared. Okay. And then plus 5a there. -1 times that times 2a is going to be -2a. And -1 times 5 is -5. So again, we have like terms right there sitting in the center. So because they're like terms, we can go 5 minus 2, which is 3. So we subtract their coefficients. So we rewrite that as 2a squared plus 3a minus 5 and box that answer. I always like boxing my answer there. It gives me that sense of success, letting me know, all right, I did get that completed, and I know that that is my final answer. So I said last time, oh, we can do these distributive arcs, these rainbows in a special way. So there's one way I like to do it. I like to do it like this, and this, and this, and this. And it starts to look like there's a happy baby in there. I kind of did that upside down. But, so you can go like that. It looks, so it kind of looks like a rainbow, and yeah, and we'll show you the happy baby on the next page. I'll tell you that. So we have r times 3r, okay, and then r times 2. We have 3 times 3r, and 3 times 2. We have those terms right there in the center that we need to combine because they are like terms. Oh, okay. Oop, I'm getting ahead of myself. Look at that. R times 3r. 3r squared. Plus 2r plus 3 times 3r is going to be 9r plus 6. Now we have those two terms in the center that we need to combine. 2 plus 9 is 11. So rewriting. And there we are. R. See, too many R's. Okay, we're not a pirate in this one. But, um, so that is the distributive property, and that's just three examples. On the next page, we'll give you a chance to check your work, and we'll work through those. Here is the new method. They call it the table method. Sometimes we call this the box method, okay, because each one of the terms is getting put in a box. And before we get into this, because we are doing, 8, 10, and 12, we're just gonna look at 7 just to get there. So if we and compare our two methods. So our previous method, we said, oh, we're taking each term in the first times each term in the second. So what we're looking at here is if we have x minus 3 and x minus 2, okay? So those are our two polynomials there. So we put a term in each of these outer boxes. All right. You can see how that gets put in there. So previously we said we showed that rainbow. And you see that here in this box. We have x times x, and that's going to be right there. Okay. And then we have x times negative 2. Okay. So you see that right here. X times negative 2. Could add a few other colors here just to help us out in seeing this. And then we have negative 3 times x. So the negative 3 times the x. Okay. And last, that negative 3 times the negative 2. Okay. And it just organizes what we were doing with the distributive property. It makes it a lot easier for us to just walk through the problem. All right. And by design, this setup makes it so we don't accidentally forget to multiply one of our terms in one of our polynomials by one of the terms in the other polynomial. So it's very nice in that regard. And you'll also see that it's an adaptation of our algebra tiles. So now we're representing algebraically our values. So and those terms. Whereas previously we had the blocks and everything that we were showing. And I mean, that's great, but we start visualizing that a little bit better here. So here we go. Let's go ahead and get into this problem number 8. So we have y plus 1 times y minus 6. So it does not matter which side. If you put the first term on the top and the second term on the side, that does not matter so long as you put one term one place and the other term the other place. All right. I have seen students accidentally put the same term both places, so just one of those attention to detail type things that we have to double check. So we do y times y for this box. So that is y squared. Y times positive 1, that's 1y or just y. Y times negative 6, negative 6y. Negative 6 times 1, well, that's negative 6. You'll notice here that our like terms are going to be right there. We need to combine those like terms. So negative 6 plus 1 is going to be negative 5, so we can just get y squared minus 5y minus 6. Box that answer. There we are. Let's try number 10. So again, 2w minus 5. We're separating those terms. w minus 3. 2w times w, 2w squared. W times negative 5, negative 5w. 2w times negative 3, that'll be negative 6w. Negative 3 times a negative 5 will give us a positive 15. Okay, so we're just walking through this. We can see that diagonal again has our like terms. They both have that variable just w. So to write it here in our standard form, we're starting with the highest power, that w squared, and then negative 6 times negative 5, or sorry, negative 6 plus negative 5 is going to be negative 11w. So we just added those coefficients, and then plus 15. Box that answer, and that's another one down in the books. Here in number 12, we may notice that sometimes we're given polynomials in a way where they're not in standard form. And so we have the ability, we have the choice to make and go ahead and make this easier up front by rearranging it so that we have 4j minus 3. But if that was it wasn't something that we had the forethought to think about, that's okay. And I'm going to show you that it's okay. It just means we got to think a little bit better at the very end when we're writing it in standard form. So we have negative 3 plus 4j. And then we have 3j plus 4. So just this first box up here, 3j times negative 3, well, that's going to be negative 9j. 3j times 4j, well, 3 times 4 is 12. J times j is j squared. Negative 3 times 4 is negative 12. 4 times 4j is 16j. So here we will notice that we have our like terms. They just happen to be on in a slightly different position for us to look at, but we're seeing that we still have those like terms. So we want to write the highest power first, which is that j squared, so 12j squared. Combining like terms, we have negative 9 plus 16, or we could think 16 minus 9 is going to be a positive 7j, and then minus 12. And that is the answer. Just right like that. So we are going to move on through to 12 through 24 evens on the next page, which is page 213. So here it asks us to use the FOIL method. This is, I don't want to say it's archaic, but this is just an old way that was taught. The FOIL, it is a way to organize the thoughts, but the unfortunate part is it only deals with the distributive property and applying it to our binomials. So when we're multiplying two binomials. So remember, binomials mean it's a polynomial with two terms. So the scope of how far we can apply it is not very far. It doesn't allow us to do problems like we see here below, where we have possibly three terms. Okay, the FOIL doesn't extend to problems like that. So it's not as good of a method because we can't extend it. That's why we started off with this distributive method. So sometimes parents or relatives will tell us, "Oh, use the FOIL method." Well, that's what they learned, and I just wanted to introduce that to you, but and let you know. But we are going to talk about that happy baby because as I said, it looks way better. So we're going to go back to doing the distributive property just to give you a chance, and then let you try 16 and 18 on your own, so we can check. So here's this happy baby. We go like that, and that, and then that, and look at that big old smile and the happy face. So that's what we call the happy baby. It's just a different take, but you can actually see that why they may have said the FOIL, and because it stands for first, outer, inner, last. So z times z is the first, then z times 2 is the outer, 3 times z is the inner, and 3 times 2 are the last terms of each of those. So that's how they got that. Now, I mean, is that the best way? No, but is it a way to do ones like this and just work through it? Yeah. Okay, but um, drawing the happy baby, it makes you smile every time you do it. I promise. So z times z squared. Z times 2 is 2z. And you'll notice that I'm specific about how I make my z's. My 2's kind of look like my z's, or my z's look like 2's. So I put that dash through the center so that we know that that is in fact a z. And then 3 times z and 3 times 2. Okay. Combining those like terms, we get z squared plus 5z plus 6. Boxing that answer. There we go. And I want you to try 16 and 18 on your own. You can use either method. So the distributive method, if you still feel more comfortable with the algebra tile method where you're drawing out those, you can do that too. Or you can do the table or box method. Uh, Either one of those work. Okay, so pause the video right here, and then I will work through these answers. If you're just now joining back, you can see how we work through those. Okay, I did one in each way. So for 16, 2m squared plus 3m minus 2 is our answer. And for 18, we got negative q squared minus 2q minus 1. Now we're looking at 20, 22, and 24. So this is just an extension of what we've been doing with the binomials. It's a binomial times a trinomial. So we can do the same methods here. All right. So we can do this distributive method where we take the 2 times the 3 squared, the 3a and the 5, and this negative a times the a squared, the 3a and the 5. So we'll notice that that we end up having 6 terms being multiplied together. So you can do either way here. Either way you choose, but it's going to be figuring out which ones are the like terms when we're here at the end. So 2 times 3a squared. So sometimes it's easier to write this intermediary step. Okay, and then we have that negative a times 3a squared, then negative a times the 3a, and that negative a times negative 5. Okay, so I need to kind of scoot things back over here. So 2 times 3a squared is 6a squared. 2 times 3a is 6a. 2 times negative 5 is going to be negative 10. So negative a times 3a squared is going to be negative 3a cubed, or 3a to the third power. Negative a times 3a is going to be negative 3a squared. And then negative a times negative 5 is going to be positive 5a. So here's when you need to be looking at combining like terms. So appears to me I only have 1 cubed. Then I'm looking for squares. I have 1, 2 that are squared. Then we have 2 that just have a. And then we have just our constant. So I want to write this from highest power to lowest power. All right. So very similar to what we did when we did adding and subtracting our polynomials, or when we were just combining like terms. So first one there, we have negative 3a cubed. And then going to our a squareds, we have 6a squared minus 3a squared. So we're going to get just positive 3a squared. And then next, we're looking for our a's. So we have 6a plus 5a, so that's plus 11a. And our last there is just that minus 10. So we can go ahead and box that answer. And there we are. Negative 3a cubed plus 3a squared plus 11a minus 10. Now we have 22 that we're going to try doing the box method on. So you could go 2 high and 3 wide, or you could go 2 wide and 3 tall. That it does not matter. I prefer to stretch it out this way just because of space on the page. So we have d squared minus 4d plus 1. And then we have d plus 3 over there on that side. So we are multiplying here. D squared times d is d cubed. D times negative 4d is going to be negative 4d squared. D times 1 is just d. We have d squared times 3, so we have 3d squared. 3 times negative 4d is negative 12d, and 3 times 1 is 3. So what's nice here is we have this organized in such a way we see our like terms in those diagonals. Okay, again, like terms are in those diagonals. So that makes this all make a little bit more sense as we're working through. So highest power first, that cubed. So we have d to the third. Then we have 3d squared minus 4d. So that's going to be negative 1d squared, or just negative d squared. Negative 12d and a positive d. So that's going to be negative 12 plus 1 is negative 11d. And then we just have that positive 3 at the end, and we can box our answer. There is one left to do. That is number 24. I'm going to have you try that on your own, so you can pause the video right here, and then we'll come back and check our answers. Time to check our answers here again. And on number 24, I went ahead and chose to do the table method. And we got 6p cubed plus p squared minus 10p plus 3. So I like the table method. That's just a personal preference. We want you to do what works for you. So when you're doing the Delta math today, get that piece of scratch paper out. This is not something you can just do in your head. You have to draw this out. You can't look at this problem and say, oh, I know how to do that. That's easy. No, you have to write it out to organize your thoughts. And the table method, our distributive method, where we're drawing our arcs and thinking about what's being multiplied by what, we have to organize our thoughts. Write that down. Get it on a sheet of paper. If you don't have a sheet of notebook paper, ask your teacher for one while you're working through those problems. So this takes practice. It takes time. The first time you do it, it's not always fast. That's okay. So uh, bring any questions back to your teachers. Post those questions in the chats in your Zoom or Google Meets, or post those questions on your Google Classroom pages. Again, Mr. Potenski here. That's all for today. Make sure you take a picture of this assignment, get it uploaded to your Google Classroom to earn points. Have a great one.